going to evaluate and determine the domain of functions. What's domain now? Not the output. The input? No, that's correlation. Okay, that's correlation. What's another name for input? X. Exactly. X. It's the X values you're allowed. Well, one key thing before we actually look at our slides are when is the domain ever restricted? And there's 2 times the domain is restricted. The 2 times domain is restricted, meaning that it can't happen. The first one, what are you never allowed in a denominator? No, I'm allowed a negative. I'm not allowed 0, that's right. So here, if I set x minus 3 equal to 0, I get x equals 3. And actually, it's not x equals 3, it's x cannot equal 3. I'm not allowed to have 0 down there in the bottom. So if I plug in 3, uh-oh, it's 1 over 0, and that's gone. So that's the first time it's restricted. The second time, now we'll go back to Sparta. Sparta, what were you saying about on the last one? Okay. But here, we're actually saying you can't have negative under a square root. So no negatives under a square root. So what kind of numbers are you allowed under there? Positive and what? What other number could I have under there? What other number? 0. I'm allowed 0. So on this one, I'm actually going to say x minus 3 is greater than or equal to 0. So if I add 3, I'm going to write x is greater than or equal to 3. So notice when it's a fraction, I tell you what numbers you're not allowed. And when it's a square root, I'll tell you what numbers you're allowed. What if I combine them both up? What if the problem had been this, 1 over the square root of x minus 3? Just trying to combine the 2 together because I don't want you to be confused. Well, since it's a fraction, what number cannot be on the bottom? 0, right? 0. And what number can you not have under the square root sign? A negative. So what kind of numbers are you allowed? Everything greater than 3? Okay. I'm actually going to say, I'm going to rewrite this whole part here, Whitney. So I'm going to say greater than 0 when I rewrite that. That way, if it's a different number than 3, it would also work. So now, x has to be greater than 3. Notice that when you combine the square root and a fraction, the only thing it really gets rid of is that equal sign there, right? The only thing it really gets rid of is that equal sign. Okay. So that's the only 2 times the domain is restricted. Otherwise, what do I write down? So it works for all real numbers. And that is this symbol right here, all real numbers. In case you forgot, it's that famous R with 2 lines in it. It's that famous R with 2 lines in it. That makes sense to everybody? Any questions? Okay, let's look at our first problem then. So go ahead, and you can actually just look at these and say which ones represent functions and which ones don't. But notice down here, you can actually turn to page 40 right now for any characteristics. And instead of me making you copy down all the characteristics in your notebook, you may just want to say, see page 40 for functions. That way you don't have to copy that all down. So we're looking at page 40 to try to figure out which ones are functions, which ones are not. Now there's 4 characteristics on page 40. The very first one says each element in A must be matched with an element in B. Here's what that means. You must use all of letter A. That means the number 2, the number 3, the number 4, the number 5, they must all be used. Okay, so which of those, just knowing that, is not a function? Nika. The last one. Because I only used 2, 3, and 5. So that one would be a no right there. Because I did not use them all. Does that make sense? Okay, the second characteristic. Say that some elements of B may be matched, but I don't have to use them all. Okay, that means I could just use the number -3, or I could just use the number -1. I don't have to use every single one of letter B, but I must use all of A. I must use all of the first one, but not all of the second. The third characteristic says 2 or more elements of A may be matched with the same element of B. 2 or more elements in A may be matched with the same element of B. So if I take a look at this third one, I've got all 4 of them in A matched to the exact same one in B. Is that okay? According to this, it says 2 or more may be. So that's a yes. That is a yes. And I'm going to show you why here. I'm actually going to graph it. So I'm going to go to 2, 1, 3, 1, 4, oh. Let's try that again. How about 2, -1, 3, -1, 4, -1, 5, -1. What famous test could I use to actually figure out if it's a function? Vertical line test, correct. So if I do the vertical line test, how many times? That only hits 1, right? Only hits 1, only hits 1, only hits 1. So that is a yes for that one. Here's the one that's hard. An element in A cannot be matched with 2 elements in B. An element in A cannot be matched with 2 elements in B. The second one would not work, that's correct. That one does not work. And the 2 I'm looking at would be 2, 0, and 2, -1. I'm not allowed to have both of those. What about the first one? Is it okay? Yeah. Now, those characteristics are lovely. They're very helpful. But do I expect you to memorize those 4 characteristics? No. So how could I do these without ever having to know those characteristics? Whitney? That's what I would do every single time. I would plot them and do the line test. That way I've got them, and it's pretty easy to work with. Does that make sense to everybody? Anybody lost, puzzled, or confused? All right, so now what we're going to do is I'm going to give you a function, and we're going to determine, I'm going to give you an equation, I'm sorry, and then we're going to determine is it a function. So go ahead and write that equation down. As you're writing it down, I want you to think of what should this graph look like? Now don't yell it out. You can discuss with your group. What should this graph look like? And why? Alright, so we're trying to figure out what this graph is going to look like. My first question to you, will it look like a line? No. Okay, because I've got an x squared and a y squared, and a line has an x and a y, they're squared. Would it look like an absolute value graph? Why not, Mallory? What's missing? Exactly, the 2 lines, right? Got that? It's not an absolute value graph. Could it look like a parabola? What's the equation on a parabola, basic parabola? Equals y, right? X squared equals y. So it's not a parabola because a parabola only has the x being squared, not the y. Now, what equation have you written, and maybe you wrote it on your quiz, that has an x squared in it and a y squared in it? It's a circle. Any anytime you see x squared and y squared, at this point, you're going to be thinking circles. So if I'm graphing this, I'm going to plot a point at 0, 0. The square root of 8 is approximately what number? Square root of 8. 2 point something. How'd you come up with that, Sacco? I agree. You know, you're right. Well, here's how I actually thought of it. The square root of 9 I can do, which is 3, and the square root of 8 is slightly below that, so 2 point something would work perfect. Okay, I'm not asking to do like the exact number, but there's the lovely graph. And does that pass the vertical line test? No. Now, let's say that you didn't know what that looks like, right? You don't know, what does that graph look like? So what letter could you solve it for? Y. We always solve an equation for y. So let's do that real quick. I'm going to subtract x squared. So I get y squared equals negative x squared plus 8. What? Square root. I agree, Justin. That's right. Now when you take a square root, what do you have to put in front? When you take a square root, what do you have to put in front? Plus or minus. So I'm going to have y equals plus or minus the square root of negative x squared plus 8. And right from there, when you see two of them like that, I should be thinking to myself, oh no, I'm not actually going to be able to make this. It's going to be two different lines on the same thing, so it's not going to pass that. Or you can always grab the graphing calculator and type that in to do it quickly. So we've got a couple different ways here, right? Any questions on that? Yeah. Yeah, that's how I graphed it. Brandon?
So whenever it's like x squared plus y squared, it's not a function?
Correct. It's an equation, it's not a function. Well, because I need to take the square root of 8. 2 point something is how we do it. Good question. Good question. All right.
That's not a function.
That is not a function. So here's our next one. And I'm just going to ask you on your own to find f of 2 and f of negative 4 and then stop for me. Okay, so I'm going to find f of 2 first. So f of 2, and that's how we write it so that I'm knowing I'm plugging 2 in for that f. Equals 10 minus 3 times 2 squared. So f of 2 equals 10 minus 3 times 4. F of 2 equals 10 minus 12, which is what number? Negative 2. Notice this is how I write my final answer. And here's why. This tells me the x value. This tells me the y value. So I can actually tell you one of the points on that equation is 2, comma negative 2. I can actually find the point right out of that answer, can't I? That will help me out if I ever need to graph it for some reason. Let's do f of negative 4 now. F of negative 4. I'm actually going to do this a little quicker. So on f of negative 4, the part that most people miss is this right here. What is negative 4 squared? 16 times negative 3. So minus 41, 48. So f of negative 4 equals negative 38. And that's how I'm going to write my final answer. I'm not just going to write negative 48. I'm going to write f of negative 4 equals negative 38. Okay? So let's do the x minus 1 together now. So if I'm finding f of x minus 1, everywhere I see an x in this equation, I'm going to replace it with x minus 1. How do I do that? How do I simplify that? Nathan? Yes. Remember, you cannot distribute an exponent if there's a plus or minus inside of there. So over on the side, I'm going to FOIL together x minus 1, x minus 1. If I do that quickly, I get x squared minus 2x plus 1. Now, I can do that quickly. I can actually do that mostly in my head because I've done that a lot of times. But if you're the person that's saying, you know what, I can't do that in my head that quickly, FOIL out x times x times negative 1 times x, negative 1 times negative 1. And then combine the middle two to get the negative 2x. That's fine. You can easily actually show that works. Or some of you can look at it and realize negative 1 plus negative 1 is negative 2. Right? So now I'm going to plug that in. F of x minus 1 is equal to 10 minus 3 x squared minus 2x plus 1. Go ahead and distribute that negative 3 now and combine it with the 10. F of x minus 1 equals 10 minus 3x squared plus 6x minus 3. Make sure when you distribute the 3, you distribute negative 3. Now I like to put it in standard form, which means I'm putting the highest exponent first, the next highest, and then I combine the 10 and the negative 3 to get plus 7. So right there is my final answer. Now, I can be very honest with you. When I took the SATs, I actually saw a problem like this right on there. So if you're able to FOIL stuff together like that, and that's really all this is checking. Can you FOIL and plug stuff in, right? You'll be able to get a nice, easy SAT problem. Yes.
Where did you FOIL?
I FOILed the x minus 1 and the x minus 1. And that's how I got this right here.
So all you did was do x plus 1.
Yep. I have to write it twice, Ryan, because there's a plus or a minus in there. And since there's a minus sign in this case, I have to write it out twice. I can't just distribute the exponent. Good question.
And one more thing. Did you get f of negative 4 to negative 32?
Yes.
Okay.
All right. Here's our next function, which will make you graph later this year again. Anybody know what these are called, though? Whitney? They're not exponential, but yes. Okay. We did do them last year, that's correct. They're not matrices. They're called piecewise functions. Because you have two pieces that make up the function. So it's been a while since you've seen this one, right? Yes, you saw it last year. Yes, you saw it last year. I could actually vouch for that. Your algebra 2 teacher, I'm sure, showed you this. And actually, she made you take a quiz on it where you had to graph it. And then on the chapter test, there was one problem like this where you actually had to evaluate, find x equals negative 2. I believe this was the chapter test question. Look at that. So it's been a while since any of you have seen it, so we're going to go through it. And what you need to know is that we have these lovely inequalities over here. Those are going to help us determine where I plug these numbers in. Okay? So let's look at the first one. We're going to find x equals negative 2. So I'm going to write f of negative 2. So all I did so far was put the negative 2 in for the x but I have to look at my two inequalities. Is negative 2 less than 0, or is negative 2 greater than or equal to 0? The top one, right? So I'm going to plug negative 2 into the top equation, meaning I'm going to plug negative 2 into 3 times negative 2 minus 4. I don't care about the bottom equation at all because it doesn't fit my constraint. And that's actually what we call these, our constraints. So let's go ahead and go through it. F of negative 2 is equal to negative 6 minus 4. So f of negative 2 is equal to negative 10. So it may have been a while since you've seen it, and right now we're just working on evaluating them. So see if you can do 0 and 2 now on your own. So now I'm going to do f of 0. F of 0. Which one do I plug it into, the top one or the bottom one? Correct, the bottom. And here's why, because it says greater than or equal to 0, so it fits that constraint there. So 3 times 0 plus 1, so f of 0 equals 1. F of 2, top or bottom? Bottom. 3 times 2 plus 1, so f of 2 is equal to 7. So for those of you that completely forgot that you did this in Algebra 2, does that at least refresh your memory? Okay? Eventually we'll go back to graphing them again, but not today. So today you do not need to know how to graph them. You do need to know how to evaluate them. Do I have any questions about evaluating? Okay, good. Good. That's what I like to hear. It's kind of easy. So now let's go. We had said today is about finding domain. So I've given you two problems here. After what we talked about at the beginning of the period, see if you can find the domain. All right, so at the beginning of the period, we talked about square roots, and if you look back in your notes, we actually say that they have to be greater than or equal to what number? 0. So I'm actually going to write x minus 16 is greater than or equal to 0. Drop the square root sign. That'll help you out. So now if I add 16, I get what I'm allowed. X is greater than or equal to 16. So on square root, I tell what I am allowed. But on denominators, I tell what I'm not allowed.
Shouldn't it be x has to be greater than, so like, it says greater than 16, because 16 minus 16 is 0.
And can you take the square root of 0?
Well, I don't think so.
What times what would be 0? So I'm actually allowed to do 0 under a square root. Okay, good question now. So on the second problem though, what number am I not allowed down here? Not allowed 0. So I'm actually going to write x squared minus 9. I'll actually just start with 0. Why not? Cannot equal 0. So I'm going to add 9. So I cannot equal 9. I'm going to take the square root. What happens when you take a square root? So it cannot equal either plus 3 or minus 3. So I've got two answers there that it cannot equal. Any questions?
I don't get that, because in a regular equation, you would take the square root of that, and it would just leave you with x equals the square root of 9, and then you get x equals 3.
Well,
So how is it not?
when you take a square root, Ryan, you have to remember you always get two answers. And here's why. If I put in negative 3 here, what's negative 3 times negative 3? Minus 9 is. So I'm not allowed that negative 3 either. It also happened to make that 0, right? So that's something I have to check for. Do I have that plus or minus?
I know what x is greater than
Well, remember on this one, anytime you're talking about the denominator, you say cannot equal 0. Okay? All better? Last one. This looks like a big, giant problem. And in fact, it kind of is. But it's our last problem of the day. So I'll give you a minute to write it down. problem right here is very famous. Well, this setup over here with the F. When you start calculus, or if you decide to take calculus, you'll start with limits. And that's the very first thing you'll do in calculus class, is working with that. So, we're not doing calculus in here, but we should be able to evaluate that. Out of those three things, we can't do anything with the h on the denominator, right? So we're stuck with it. What thing can you do though? I can't cancel it out. What item can you find? Howard. Go ahead, what were you going to say? You're correct, I cannot do that. But I can find f of 4 plus h. Go ahead and plug in 4 plus h into that equation. Means I'm going to write 4 plus h squared minus 2 times 4 plus h plus 9. What do I need to do right here with the 4 plus h squared? FOIL. I'll do that over here. F of 4 plus h is equal to h squared plus 8h plus 16. Now here I'm allowed to distribute. So minus 8 minus 2h plus 9. Go ahead and combine your like terms. H squared plus 6h. 8 plus 9 is 17. Okay. Now I need to find f of, so I found this part, what do I still need to find? F of 4, let's find that quickly. F of 4 is equal to 4 squared minus 2 times 4 plus 9. So notice I did it in pieces, right? First piece, second piece. Stick with me for one more minute, we're almost done. Now let's plug it in. Here's the first piece minus the second piece, so minus 17, right? What happens to the 17? So I have h squared plus 6h over what letter? I took the first piece minus the second piece. So if I put that over h, now on this case I can simplify the h's. So I get h plus 6, and that's the answer. That's it. I crossed out an h there. I crossed out an h here. See how I did that? All right, essential work.